Okay, let's look at these two equations here. What we're going to look at in this set of videos is simultaneous equations. And what solving simultaneous equations allows us to do is it allows us to pinpoint the exact point on a graph where two different equations cross over. So here we've got the equation x plus y equals 5. Here we've got the equation x minus y equals minus 7. Okay, so we're going to have a wee look through this and see how we get on, but we're going to do this kind of two different ways. There's a way that we can do it graphically by using graphs, and there's a way that we can do it using algebra and eliminating. In this first video we're going to look at graphically. So we have got the equation x plus y, that is equal to 5. X plus y equals 5. Remember, if I wanted to graph an equation, I've got three options. I can do a table of values, I can compare it to y equals mx plus c, or I could look at where it crosses the x and y axis. What I'm going to do is I'm going to compare it to y equals mx plus c. So to do that, I'm going to take away x from both sides, and I'm going to have y equals minus x plus 5. If I were to compare this with the equation y equals mx plus c, we can hopefully see that the gradient is minus 1 and c is 5. So it crosses the y-axis at 5 and it has a negative gradient. And my other equation is x minus y equals minus 7. X minus y equals minus 7. So I'm going to compare this with y equals mx plus c, so it doesn't look similar. So I want to have a positive y, so I'm going to add y to both sides here. So I'm going to have x equals y minus 7. I'm going to rewrite that round the other way. Y minus 7 equals x. Then if I add 7 to both sides, I'm going to have y equals x plus 7. If I compare this to y equals mx plus c, I would hope to see that the gradient is 1 and the y-intercept is 7. So all I've done here is I've just rewritten both equations in the form y equals mx plus c, and that is going to allow me to plot them and draw them. Okay, if we were to look at this first line here, this corresponds to our first equation, y equals minus x plus 5. Y equals minus x plus 5. So the plus 5 is the c part, so that means that this line crosses the y-axis at 5. Yep, and it's got a gradient of minus 1, so it's going down the way, which it is. And that every time it goes 1 across, 1 down, 1 across, 1 down, 1 across, 1 down. Okay, that's the quick way to plot this line. Similarly, with the equation y equals x plus 7, it's going to cross the axis at 7, and it's just going to get a gradient of 1, so it's going to go up 1 each time. So there's the quick way to plot those. And we can see clearly that there is a moment where these cross over. We can see that it crosses over exactly at this coordinate here. This coordinate we can state is minus 1, 6. So the solution to that pair of simultaneous equations is minus 1, 6. So all we did was we rearranged the equations to get them into the form y equals mx plus c. We drew them on a graph and we found the point where they crossed over, and that is the solution to the pair of simultaneous equations. So that's the graphical way to solve simultaneous equations. But more conventionally, we're probably going to be expected to do it algebraically.